Great. Thanks, Andy and ICANN for inviting us here today. I'm happy to share the Allen Coral Atlas here.
There, your slides are coming up here.
Great.
There we go.
Can you see that?
Yes.
Excellent. My name's Wolf. Thank you. I'm going to share the Allen Coral Atlas, a global tropical mapping and monitoring project. This new tool for coral conservation is a collaborative effort, and I'm not sure why it keeps changing. Sorry about that. It's a collaborative effort and with the partners.
Brianna, I'm sorry to interrupt you. Maybe if you would like to click on the third one. Just switch it. The third that says swap display and then presentation mode.
Okay, can we just do the slideshow then?
Oh, there you go. Can you see that all right?
And swap display.
Yeah, there. That's good.
Okay, thank you. Okay, I hope this short Atlas presentation leaves you with more tools for coral conservation, including assessing the UN Sustainable Development Goals. So first, I want to highlight my Atlas colleagues. Since this has been a true team effort, the Atlas builds on the vision of the renowned Dr. Ruth Gates and philanthropist Paul G. Allen, the co-founder of Microsoft. This co-author list is just a subset of those working on the Atlas. So I'm Brianna Bambic, and please feel free to contact me or our team. Right now, I'd like to invite you to the allencoralatlas.org. This is our website homepage. You can click on the full interactive page up here on the top toolbar. We are happy to announce all tropical benthic and geomorphic maps were completed this month, and you can check out a new blog, the science and methods behind the map, which I won't get too much into today, but it's highly fascinating. And we couldn't have made these maps without the global coral reef community. So to set the stage, our team has a few goals for today. First, we'd love you to check out the maps again at allencoralatlas.org. We hope to connect with the International Coastal Atlas community, so you all have access to not only the Atlas platform, but also the training resources we have freely available. We at the Allen Coral Atlas also want to collaborate with you on all shared best practices, lessons learned, collective capacity building, and identifying gaps in knowledge. We encourage you to follow up with us at support@allencoralatlas.org for any other comments, since we are short on time today. I'm going to get right into it and say that the Atlas started with two major challenges. As Charles Darwin discovered, mapping reefs is not as straightforward as observing and mapping land. They are more difficult to see with the naked eye and harder to map on a larger scale. As coral reefs are one of the most biodiverse and threatened ecosystems on the planet, how are they still largely unmapped and unmonitored? So our team took on this challenge twofold by creating the world's first globally consistent map and monitoring system by using millions of satellite images, algorithms, and semi-automated based learning. We were able to collaborative and with a collaborative effort from scientific community, we were able to have a free and accessible tool for all researchers, managers, and conservationists around the globe. Here's quickly how it came together on a global scale in about 4 minutes. The Atlas, it started with Planet Inc.'s fleet of over 150 Dove satellites circling the globe, collecting the best 3.7 meter resolution imagery that you can see here. Then Arizona State University's unique ability to essentially peel back the seawater corrects for cloud, sun, and wave reflectance. We will use the satellite imagery of Tonga Island As an example, inside the red circles lie islands, and here you can see an incredible level of detail of the surrounding reef. First the image, next the map. Here, University of Queensland Remote Sensing Research Center uses field data collected by survey teams and existing data sets to generate the map with object-based analysis and machine learning techniques. Each color represents a different benthic class, for example, microalgal mats, sand, and coral algae combined layer, down to the depth of 10 meters. These maps are being used by NGOs and governments to prioritize environmentally and economically sensitive areas, as well as habitats for key species. Moving on, we also have available the first ever globally consistent geomorphic map that condenses dozens of reef categories into 12 globally consistent geomorphic classes down to 15 meters. These maps are being used for aquaculture suitability sites, coastal erosion, and sea level rise analysis, as well as post-cyclone disaster relief assessments for prioritizing coastal recovery and future sustainability projects. Next, the Atlas also includes a quarterly turbidity monitoring system by Arizona State University. This is a sample turbidity image, since it is for download only and shows the highest level of turbidity per pixel for the quarter at 10-meter resolution. Curious minds could look into how the land and sea interact and prioritize land-based conservation projects. To show you the newest Atlas feature, which detects global coral bleaching, let's travel to a beautiful island in Indonesia. This archipelago was monitored July 5th of this year. As surface temperatures became warm, NOAA's Global Coral Reef Watch sends bleaching alerts as shown in yellow. So when a region signals a bleaching alert, the Atlas bleaching detection tool is initiated. Next, we're going to zoom into the north of the archipelago. You are able to see different bleaching severities across the islands, shown in low bleaching as yellow, moderate in orange, and severe in red. So we are curious how your team might use the Allen Coral Atlas bleaching detection for SDG 13 as the climate action for motivation for climate action. And so next, how are we using the maps and monitoring system? Here are other ways the Atlas might be using them by identifying, prioritizing biodiverse areas, such as Sri Lanka, that have multiple stressors. They want to prioritize environmentally sensitive areas for conservation, or monitor areas of erosion. As in Vanuatu, a team there is identifying high-risk areas to prioritize land and conservation upstream. And finding patterns in coral health, potentially applying different geospatial data layers to assign a metric for coral health using the Allen Coral Atlas, combining species and habitat together. And lastly, to inform policy, for example, 30 by 30 and SDG goals. So here right now, 70 countries have signed up to the NGS High Ambition Coalition to reach 30% of land and ocean protected by 2030. In order to monitor progress against the UN CBD goals, the Atlas provides a consistent metric. In this mock example, you can see in yellow what 30% of protected coastline of Montego Bay, Jamaica would look like compared to the entire coast coral reef extent found by the Allen Coral Atlas. Coral reef extent is likely to be a headline indicator in the draft Global Biodiversity Framework being drawn up by the Convention of Biological Diversity. And the Atlas is positioned to be the tool for individual countries to then measure their own coral reef extent and progress toward conservation goals like 30 by 30 initiative. Another example is prevention of marine pollution of all kinds is another UN biodiversity goal. Another indicator could likely include the Atlas turbidity layer to be a metric in the index of eutrophication when assessing regional and temporal differences. Next, the Atlas has a new easily accessible World Database of Protected Areas layer, or WDPA, showing protected areas. The Atlas shall play a huge role in remotely managing marine and coastal ecosystems and assigning how much of the EEZ zone is being protected through ecosystem-based management approaches, as this example here shows in Indonesia. These are a few ways the Atlas is being used on a global and regional scale. And we would invite you to contact us through our social medias, encourage encourage any sort of connection, or through our newsletter to hear more about new features, try out some of the tools and the data downloads, or reach us on our support line. I'll put a couple of these threads in the chat. We are actively seeking feedback since we are prepping for version 1.2 due to improvements of technology and ground truthing process within the last 3 years of mapping. And I just want to thank everyone for contributing data who has helped along the way. And again, we just ask for collaboration. If you have any ideas of other AI and scalable coastal projects, we welcome that. Any best practices, ideas on building capacity and identifying knowledge gaps. We'd love to hear your projects or proposals, so please get in touch. And that is all.
Great. Well, thank you, Brianna, for that great talk. And we should all go and explore the Atlas and see how we can contribute to these important coastal ecosystems. So we have a question from Carolina. Hang on. So I don't know whether you see it. Do you have Caribbean data?
I can see it. Yeah. Do you have Caribbean data in the Atlas? And yes, we do. We have Caribbean data in all of the areas just was mapped this month. So if you go to allencoralatlas.org to the Caribbean area, I could screen share again too to show you, but it's very easy to find. You navigate using the search bar and which areas. All of the areas from 30 degrees north to 30 degrees south is mapped. We do have some missing areas due to turbidity, but all along the Mesoamerican reef is mapped. Parts of Mexico on the Pacific is missing, but if you go further down, we have reefs in Costa Rica and islands, far off islands from Costa Rica and Colombia off. So deep water and coral.
Cold water coral.
Cold water coral was the next question.
Yeah.
From Jeff Herter. So we don't have deep water corals yet. Right now, the maps are down to 15 meters and 10 meters for benthic maps. However, if there is a push, I know, to map deeper corals and there's an idea for scalable, we're definitely interested to hear from you. So thank you for that question. It's always up there as a common one.
I think Canada has some data on deep water corals off the Atlantic coast. I know. Maybe I could put you in touch with the people that are working on that.
Great.
Okay.
Yeah.
There was another question that just popped up there.
Do you have any information of Persian Gulf coral reef? We have mapped the Red Sea and the Amman Peninsula area, and so if you want to go to the Allen Coral Atlas, we have information on that. Again, like I said, we're in the 1.0 beta version of the maps, and there is potential for new data to come in if others come to us with local knowledge. And we're trying to, like I said, there was like 400, or maybe I forgot to mention, but there's over 450 researchers that collaborated with us to find information, and to help our algorithm and machine learning process. So if there's more information on the Persian Gulf, we'd love to hear from you, but we do have those maps available.
Right. I see that Ned had a question, but maybe it's a bit too complicated to. I think you already answered it in the presentation about ground truthing. Your satellite stuff is ground truthed, where you can get information from collaborators.
Yeah, I definitely encourage people to look at the research and methods page. It's really interesting, the ground truthing protocol, the habitat protocol that was used. Because of COVID, we weren't able to get research teams all over the world to actually get in the water. So we relied a lot on existing data, which there was a plethora of, like we said, 450 researchers there. And again, this is a satellite-based project. So we use a satellite-based imagery to identify pixels, and that's how the maps produce. So that is why it's difficult to see deeper water. However, I know there's new technology coming out all the time. And so there could be a potential in the future.
Anyway, I think we'll stop there. Thank you very much, Brianna, for a great, and we encourage everybody to go and visit the Coral Atlas and think about how it could, we could make it better. Great.